Today we are going to do the meter bridge 1 experiment. The aim of this experiment is to find the unknown resistance of the given wire.
This is the meter bridge apparatus. The other apparatus needed are battery eliminator, resistance wire, key, galvanometer, jockey, high resistance and resistance box.
Meter bridge is an application of Wheaton's bridge principle. According to Wheaton's bridge principle, X by R is equal to L by 100 minus L. Here unknown resistance X is equal to RL by 100 minus L, where R is the resistance taken in the resistance box and L is the balancing length. X is the unknown resistance. Let us start the experiment.
The meter bridge consists of a 1 meter long resistance wire and a meter scale. There is 2 L-shaped strips and 1 I-shaped strip. Each strip consists of 3 terminals. Connections are made as shown here. The terminal A is connected to the positive terminal of the battery eliminator. The negative terminal of the battery eliminator is connected to one end of the key. The other end of the key is connected to terminal B of the meter bridge. This is the left gap of the meter bridge. The resistance wire of unknown resistance is connected here. This is the right gap of the meter bridge. The resistance box is connected here. From the center terminal of the I-shaped strip, connection is made to one end of the high resistance. From the other end of the high resistance, connection is made to the negative terminal of the galvanometer. The positive terminal of the galvanometer is connected to the jockey. The key is closed and the battery eliminator is turned on. A resistance 1 ohm is introduced in the resistance box. The jockey is pressed first at A and the galvanometer deflection is noted. Again, the jockey is pressed at end B and the galvanometer deflection is noted. If the galvanometer shows deflection in the opposite directions, connections are correct. The jockey is moved over the meter bridge wire till the galvanometer shows null deflection. The balancing length L1 is measured from the side of unknown resistance. Here it is 20.7 centimeter. Interchange the position of resistance box and unknown resistance wire. Now, resistance box is in the left gap and unknown resistance wire is in the right gap. Find the balancing length for resistance 1 ohm. Here the balancing length is 13 centimeter. Now, a resistance 2 ohm is introduced in the resistance box. The jockey is moved over the meter bridge wire till the galvanometer shows null deflection. The balancing length L1 is measured from the side of unknown resistance. Here it is 12 centimeter. Now, interchange the position of resistance box and resistance wire. Find the balancing length for 2 ohm. Here, the balancing length is 10.5 centimeter. Now, a resistance 3 ohm is introduced in the resistance box. The balancing length L1 is measured from the side of the unknown resistance. Here it is 8 centimeter. Interchange the position of resistance box and resistance wire. Find the balancing length for 3 ohm. Here, the balancing length is 9 centimeter. Now, a resistance 4 ohm is introduced in the resistance box. The balancing length L1 is measured from the side of the unknown resistance. Here it is 6.5 centimeter. Interchange the position of resistance box and resistance wire. Find the balancing length for 4 ohm. Here the balancing length is 7 centimeter.
Observations and calculations of meter bridge. We already noted the values of balancing length when resistance wire is in left cap and right cap. Now we have to take the average of those two lengths. So here it is 20.7 plus 13 divided by 2, and that is equal to 16.85. Likewise, here also 12 plus 10.5 divided by 2, and that is equal to 11.25. Here the balancing length is 8.5 and here it is 6.75. Now we have to calculate 100 minus L, where L means the mean balancing length. So here it is 100 minus 16.85, that is equal to 83.15. Likewise, here it is 88.75, here 91.5, and here it is 93.25. Now we have to find out the resistance of the given resistance wire. The equation for finding the resistance, X is equal to RL by 100 minus. For first observation, the value of R is 1 and L is 16.85 and 100 minus L is 83.5. When substituting it, we get 0.202. Likewise, we have to find out the other values also. Here the values of X are 0.253, 0.278 and 0.28. Now we have to find out the mean value of X, that is mean value of resistance of the wire. So mean value of resistance X is equal to 0.202 plus 0.253 plus 0.278 plus 0.289 divided by 4, and that is equal to 1.26 divided by 4 is equal to 0.315 ohm. So this is the mean value of resistance. Now we have to find out the conductance of the wire. So we know that conductance is the reciprocal of resistance. So conductance of the wire C is equal to 1 by X, that is equal to 1 by 0.315. So here the value of conductance is equal to 3.174 ohm inverse.